Hey everyone, welcome back to the channel. Today we are diving into one of the core concepts of concurrent programming in Golang, which is mutexes. If you have ever dealt with race conditions or needed to protect shared resources in your programs, then this video is for you. Okay, we will go over what a mutex is, why it's important in Go, and of course, how you can use it in your own programs. So grab your coffee and let's jump into it. Okay, in Go, mutexes are part of the sync package. Like in previous video we discussed about weight groups, it was also the part of the sync package, and they are used to provide mutual exclusion. What does that mean exactly? Well, in a multi-threaded, or we can say that concurrent environment, we often have multiple Go routines trying to access shared resources like variables or data structures. This can lead to race conditions, unpredictable behavior due to simultaneous access. To prevent this, we use mutexes. A mutex is a locking mechanism that ensures that only one Go routine can access a shared resource at a time. If a Go routine locks the mutex, other Go routines have to wait until it is unlocked before they can access the resource. Now, let's take a look at how you can start to use a mutex in Go. I am going to show you some example where we use a mutex to protect a shared counter. So let's code. As we start the new Golang program, package main, import, enter fmt. Now we need to call the sync package, as mutex is part of the sync package. We will have a variable counter which will be assigned as 0. Then we have one variable mu which is for sync.Mutex type. Like we have new variable in for weight groups. You can look at the previous video in part 13. Okay, now we will make one function which I will name as increment, and will give wg sync.mutex. okay, no, we'll give it sync.weight group because we need counter to handle the Go routine. Sorry, it should be weight group. Now we will log the counter, that is mu.log. It is a method in mutexes which is like the ones in the weight groups. We had three, like we have in weight groups add, done and wait. Similarly here we have log and unlock. Okay, then we will unlock it after our counter is increased. Then we are done with our thing. We want the counter to close. Now we will write function main. We will create a new variable wg, that is sync.weight group. Okay, we will create one loop. Sorry, my pointer just. For I is equal to 0, I is less than 10, and I plus plus, then wg dot add the counter, and we will increment it to the 1 every time as we goes to I value, increment, and we will pass this wg address there. Okay, now we want wg dot weight and fmt dot print ln, that is final counter. Okay, so here is our basic program to demonstrate the mutex. So in this program we have a global counter variable that is 0 that multiple goroutines will increment. The problem here is that if multiple goroutines access this counter at the same time, we could get inconsistent results due to the race condition. Okay, to solve that we have used mu, that is mutex. Here how it works: locking, before a goroutine modifies the counter, it locks the mutex using mu.lock in line number 13. It ensures that no other goroutine can access the shared resources while this one is working on it. Okay, then unlocking part is there. Once the goroutine is done, it unblocks the mutex with mu.unlock, which is the method in mutex, allowing other goroutines to safely access the counter. The sync.wait group ensures that the main function waits for all goroutines to finish before printing the final result. Now let's see what happens when we run the program. Okay, I need some spelling mistake. Yeah, we are getting the final counter as 10. So when we run this program, the final counter will always be 10, no matter how many times we run it. Let me run it 2-3 more times. Okay, that because the mutex ensure that each goroutine increments the counter one at a time, preventing the race condition. If we don't have the mutex here, then the final counter value will be keep on changing every time we run it. Okay, if we didn't use the mutex, okay, the condition would be that. So this is all. Before we wrap up, here are the few important things to remember when using mutexes in Go. Number 1, always unlock. If you forget to unlock the mutex, your program will go into deadlock and no goroutines will be able to proceed. So make sure to always unlock in a defer statement if possible for safety. Number 2 is minimize lock time. You should lock the mutex only for the time you really need access to the shared resource. The less time the mutex is locked, the less likely you are to block the goroutines unnecessarily. Number 3, avoid nested locks. Be careful when locking multiple mutexes in different parts of your code. Nested locks can lead to deadlocks where two goroutines are waiting for each other forever. Okay, so that's it. Now you know how to use mutexes in Go to protect shared resources from race conditions and ensure your programs are thread safe. If you found this video helpful, don't forget to like, subscribe and hit that bell icon so you don't miss out our future tutorials. Also, if you have any questions or want to share your own experiences with mutex, drop a comment below. I would love to hear from you. Thanks for watching and happy coding. We will see you in the next video. Thank you.